Okay, welcome. Sorry. Today I want to talk the work you draw the project I built using Python that combine reinforcement learning and game simulation to create an intelligent blackjack playing agent. So let's start. The first step that I built was import the necessary libraries: Matplotlib, NumPy, Collation, Gymnasium, TQDM, and Seaborn and Python. Okay, so I create a Jupyter notebook where AI at learn the AI agent learns how to play blackjack using Monte Carlo Control with an epsilon-greedy strategy. In first in these first lines, you can see the agent. The I I use the Black version 1 environment from OpenAI Gymnasium, which simulates the card game with simplified rules. The agent plays 1 million, yeah, episodes exploring different actions, hit or stick, based on the current stake, and the agent maintains a queue table which stores decimal rewards values for each state action pair. Over time, it learns which action maximizes its chances of winning by averaging the rewards it receives. I apply the epsilon decay. Uh, yeah, epsilon decay in this to slowly reduce exploration and focus on exploitation as training process progress. Once training is complete, I deliver the optional polites, mapping each stage the base action. Mapping each stage of the base action, this polite is able using Python. In here, I also visualize the polites using heatmaps, showing clearly when the agent chose to hit or stick depending on the player total, the dealer showing card, and whether the agent hold and possible ace. Finally, I plot the average reward trend because it's to ensure learning is stable and proper over time. So test the code again. It's because the process to learning or training the agent is a very short time, 1 minute, 1 minute half. Sorry, I forget how to say that in English. So restart the process, clear all outputs and root all. Start import the necessary. Start here, and could you see the training agent is very fast because I only put 1 million episodes. If I change the episodes to, I don't know, 4 million, 10 million, or similar, maybe the agent is better, or maybe no. So with we prepare the training agent is finished. I can see explain the code, the the app. So um, the explanation and gameplay. The app is using the training police. For example, in this moment, yeah, it's better wait for the training because maybe it's a bit confusing. Change the blackjack to the app. So waiting a moment to see. In this moment is finally the process. You can see the process with the teller showing it's a bit weird. Maybe we can train in the process, but first I need to open record over time. Okay, maybe it's good. So now, um, again with this part, not using the training policy, I built a full interactive blackjack game in a Python console application. The app, the app offers two modes: human versus AI versus dealer. You play alongside the AI agent. Each each of your starts with two cards, and you choose whether to draw more. The AI uses the learning policy to make a decision. The teller plays by the standard blackjack rules, hits until 17. At the ends, the results of the game are shown allows with visual ads card. In this moment, yeah, we can see display the cards. Mm, win, tie, or lose counts are tracked and visualized in a how to say that, in a part chart comparing human and AI performance. Um, the next scenario, or the next that simulate, was a AI versus dealer simulation. This mode run 1,000 simulate games where the AI play against the dealer. No user input is needed; it is fully automated. After the games, um, after the games, sorry, I need to localize again my word. Okay, no user input is needed; is fully automated. After the game, a chart is displayed to show how many times the AI won, lost, or teller. Both modes log every game into a text file, which is great for review behavior over time. Okay, we can see, for example, in this case, to train or play 10 games. So, give me a second. Python. So I played 10 games. In this case, I know. Oh God, the dealer was very lucky in this case. Okay, now the dealer, what happened here? Two, one more. Oh God, the dealer have a good luck. Um, I prefer plant. Okay, the dealer posted. Mm, I prefer them. Okay, again, I plant. Okay, win. No, here. Okay, perfect. No, here I plant. Finally, the last game. Okay, okay. For example, in this case, I lose more time, and the agent is better than, than this case. Was 7. Okay. Simulate 1,000 games with the agent and versus dealer. This case, for example, the agent played win 400, tied 71, and lose 15, 11, no, 5,011. So it is interesting. And we can train again with the agent. In this case, I have a curiosity because in this head map is a bit, I don't like it. So I prefer maybe this case the learning enterprise is better if we train with another paragraph such as hyperparament. Um, yeah. What else? Yeah. In this case, we can see, for example, the file, the blackjack log. This case, we can see, for example, the cards that that I have in the first game. In the agent have the dealer card. This case, the dealer won again. I don't know. I think the dealer maybe maybe she is the game. This case because 3 times 20 is like that, like very 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 weird. So we can see here the last game was his. Okay, maybe. Okay, it looks like a bit better. Okay, okay. And exit. Going to the CMD. Okay. Okay, again. This game is hmm. Oh god. Another now here. Okay, it's give me another card, please. No, I stay. Okay, what? Mm, no, here. Okay, 2 games more. Maybe this blackjack is a bit addictive because you could be better if you train the agent to want to showing something. So again, another card, please. Okay, And the last game, oh damn it. Okay, this game is I think maybe I lose. Yeah, I lose. In the second, okay, mm, Legend maybe can be improved, but it's okay. I think it's over. Okay, we can see every code and everything. So, to finally, the simulation helps visualize how well the training aid performs. It's also a fun way to demonstrate how artificial intelligence can make decisions in a real-world like scenario. Uh, this project was a great opportunity to combine my knowledge of reinforcement learning with game logic and data visualization. And the quote today was the most important thing is to try and inspire people so that they uh, okay, sorry again. The most important thing is to try and inspire people so that they can be great in whatever they want to do. That's the first by Kobe Bryant. It's brilliant. I hope this project inspired you to explore artificial intelligence or agents and build something fun and meaningful. Thank you, thank you for watching, and I hope you have a nice day, nice night, and nice afternoon. So thank you so much, and see you the next time. Bye bye.